Okay, so as I said, we're starting our first learning target under expressions and equations. So whenever you see this EE and a different number here, we've moved into a different target within that expressions and equations unit. So our learning target for today is I can write and evaluate expressions with exponents. Now, this is a lot of information in one target. So we're going to break this down into a couple of days. So today we are going to focus on just the writing expressions. Okay, now as we talk about expressions, there's some key terminology that we make sure that we understand. And the first one is called variables. Now, when you see the word variables, this is where you may see letters or symbols in math being used. Now, these letters or symbols are going to represent some kind of value or number. Yes, Daniel.
Can I borrow a pencil?
You can borrow a pen.
The next one that you need to know is operations. Now, when we talk about operations in math, we're talking about addition, subtraction, multiplication, division, and some other things that you may have seen yesterday also in Study Island is the use of parentheses, the use of brackets, or the use of braces. Okay, now the last one is one of our main focus, and that is expression. Now, when we talk about expression in math, we're talking about combining the letters, the numbers, and such, and along with operations to represent a value. And at times you might see a combination of both numbers and letters. Sometimes you may only see one of them. Okay, so where we're going to be focusing on writing expressions today, let's go ahead and take a look at some examples of what expressions may look like. Okay, you might see an expression like 3 plus 2, where we have two numbers that are being combined with an addition symbol. Again, you might see something like 7 minus 5. Again, two numbers that are being combined with a subtraction symbol. Now, you've been seeing expressions since you were pretty much in kindergarten. You just may not have called them expressions. Now, a lot of students will look at this and say, well, 3 plus 2 is 5. That would be the evaluating piece. But today, we're not going to focus on the evaluating yet. Okay, we're just going to look at expressions and writing them. We might look at problems like x divided by 4, where now we have a letter involved. We're performing an operation and we have a number also. Now, we don't know what x means. We don't know what value it stands for, but it does stand for some value. But this right here, do you agree, could have infinite possibilities for its value, depending on what x is. The minute I define x, though, and if I said x is 4, we know that this value has to be 1. But if I don't define what x is, then we can't find the value of that expression yet.
So is the letter going to always represent the same number?
If I use x in a particular expression, and let's say in the same problem I use n, then yes, x should represent the same value.
Oh.
But if x is a completely different problem, they could have different values.
Oh, okay.
Does that make sense?
Yeah.
used within the same context, it should have the same value. In different problems, it could have different values. Now, with division, you might also see the problem written like this. This is also an equivalent expression to the above one. It's just written using that fraction bar. So I'm going to put a little or up there. And you might even use the standard algorithm, where again, all these are saying x divided by 4. They're all equivalent. Now, if I go back to my first example of 3 plus 2, do you agree that I could write that as 2 plus 3? And it would still be equivalent?
Yes.
Could I rewrite this one as 5 minus 7?
No.
No. So you have to be careful. Some operations you can change order, but other operations you can't. And we will be talking about that later on as we're evaluating also. So is everybody okay with these division ones being equivalent?
Yes.
Okay, now let's go ahead and look at a multiplication one. So normally if we have two numbers, this is how we show that we're multiplying them. Would you agree? And I could change the order. I could say 3 times 4. And that's okay. But a lot of times this time symbol gets mistaken for the letter X. So whenever we use variables, we try not to use the multiplication symbol. You might see a dot used.
Oh, and that's why you write the X like.
You might even see parentheses being used. So these are all ways that you can show multiplication. Now sometimes we might combine numbers with letters when multiplying. So let's say if we had the value 4 times x. Notice to show 4 times x, I do not need anything between those two values. It is just a number and right by the letter. That also means multiplication. And same thing if you had 2 letters being multiplied. If you see 2 letters right next to each other, this actually means x times y. So all of these are forms of using multiplication. Now be careful. Would I want to put 2 numbers right next to each other to show multiplication? No, if I did 4 and 3, I wouldn't think of that as 4 times 3. I'd be thinking of it as the number 43. So whenever you use numbers, make sure you use some kind of operation symbol with that. Okay, along with basic simple ones like this, sometimes you might see a combination. And in this case, we may have to use parentheses. And the parentheses are telling us we have this number, subtract 3, that we then need to multiply by the value of 4. And again, you might see it with a dot. You could even see it with the multiplication symbol. But be careful to make sure your multiplication symbol looks different than how you would write your variable x. And I usually use kind of a fancy lettering to write my variable of x, and I keep my multiplication symbol very simple when I'm using those. Okay, so these are just some examples of what expressions look like. Okay, so today though, we are going to focus on keeping our expressions very simple. So we are going to focus on just 2 operations. And the 2 operations that we're going to focus on are addition and multiplication, where we're going to be writing some equivalent expressions. And again, today we're just going to focus on addition and multiplication. Now, what do you know to be true about addition and multiplication? Why do you think I'm grouping these 2 together? Merritt?
They're both adding like they're adding numbers or something?
They're both involving addition. Ayla?
They're positive.
And they're both positive.
Addition, they're pretty much the same thing except X is added multiple times.
Yeah, in fact, when we multiply, we usually say it's like repeated addition. So these two go hand in hand. They are operations that are very similar in that respect. So we're just going to be focusing on these two today. So if I gave you an expression of 2 plus 2 plus 2, could you think of an equivalent expression to this that would use multiplication? Daniel?
3 times 2?
We could do 3 times 2, or do you agree we could do 2 times 3?
Yeah.
Either one, however you want to describe it. But basically this problem is saying that we have 3 2's that are being added up. And usually when we look at that multiplication, we can say that it's 3 groups of 2. Now, when I look at 2 times 3, that also could be written as the same as 3 plus 3. So now we also have another equivalent addition statement that we could say. We could do 3 plus 3. And again, that would give us, in most cases, we would say that would be the 2 groups of 3, and this one would be our 3 groups of 2. But would you agree that every one of these are equivalent? And the reason why they're equivalent is because they give us the same value if we were to evaluate them.
I don't understand how 2 plus 2 plus 2 is equal to 3 plus 3.
Well, let's actually figure this out. What is 2 plus 2 plus 2?
8 or 6.
6.
Oh,
What's 3 plus 3?
sorry.
Yeah, and that's what I meant by that they give us the same value.
Okay. I know what 4 plus.
Yeah, I know, and Merritt, I totally see what you're saying, because you're like, one's using 2's, one's using 3's, but we'd almost have to look at the final product.
Okay.
And that final product of what we would be getting, that final value, would tell us that they're equivalent. Now, what if I did an example that looked like this? 3 times A. What do you think an addition statement could be written as that would be equivalent to this? And I want you to take a minute and talk within your table groups. Okay, now if we look at the example, would you agree 3 times 2 looks very similar to 3 times A? It's just this one has both numbers, this one just has a letter involved. But they're both saying 3 times something. Would you agree? Now if we said 3 times 2 meant 2 plus 2 plus 2, we said, hey, it's 3 groups of 2. What do you think 3 times A means? 3 groups of A. Would you agree? So if that's the case, we would have A plus A plus A. So you can see that we have 3 A's here and 3 times A. So that would give us that equivalent statement. Now, I heard some students talk about, well, that's the same as 3 plus 3 plus 3. What do you think? Is that the same?
No.
Well, what's this 3 groups of?
3.
That's 3 groups of 3. Is that the same as 3 times A? No. If A equals 3, it would be, but we don't know what A equals.